In front of our audience today, I will be talking about our new product, PostgreSQL sharding, but I would like to start with a different topic, quite a popular one when we talk about distributed systems, about shared systems. I would say a few words about the reasons why actually recently they are getting more and more popular. And also, I will extrapolate a little bit more on a number of projects and aspects which is particularly interesting that actually database users want to see, and then I will proceed to some conclusions. We'll say a few words about motivation, why we decided to create these products. So if we talk about development, about applications, very often it makes sense to use a special database because we represent certain instruments for various tasks. We actually reflect productivity, and in general, it's always the case. But if you look at the situation from the business point of view, it is not always best optimum solution. Why? Because the data that's generated by one application can also be used in other areas for other services, and so their requirements can be different, and as a result we might have quite a number of systems, and this approach has its own disadvantages. It means that we store a number of copies, and since the data grows inside, so we have to store a lot of copies, and of course costs go up. Then we get a structure that actually needs to be supported, maintained, improved, and of course it takes time. Very often we see that data that's generated by one system then used for some other purposes, and if we transfer it from one system to another, we sometimes risk losing relevancy of data. And also we shouldn't forget about maintenance, either about updates, about safety issues, security issues, and we really need to focus on maintenance. As a result, the prices really go up. We might come to the conclusion that one of the solutions here could be a universal database. I would like to consider some of aspects why we actually should talk about that when we talk about universal nature of a database. Something that's is particularly important. It reflects basic requirements for database. So let's proceed to the type of loads. I think that there are two major types of loads. So the first one is transactional loads, which mostly meant for transactions, for operation that is critical data for any business, and of course we set quite high standards and requirements for the reliability of such systems. At the same time, as for queries, we usually have a quite limited amount of data, just some lines, selection, changes, etc. This type of loads identified storage type, also use of this data. We also have a different approach here to indexes, and when we want to select one line, we don't have to work with the whole system, but use a special data structure in order to efficiently retrieve this data from the system. As for resources, the main load goes to the disks. At the same time, we don't have any considerable assessment tools there or computing. As for analytical loads, it's a little bit different. So their reliability is a bit different. That is kind of copy of data, and even if we lose this information, that is less scary. On the other hand, their computing side is way more serious, and very often we make very complicated computing, working with table columns, we work with modules, with aggregates, with different connections, and other difficult estimations. Also, we used column-based storage because we don't want to take all the lines. We only have to retrieve one column, for example. And since we have quite considerable computing capacity, we resorted to optimization, inventory, and also inquiry compilation. Traditionally, these two systems, well, first of all, these are two separate systems, but at the same time, they are linked by means of some technical processes, and they are also communicate. So data from one system goes to another one. We also have additional separate systems and separate directions where we try to process both types of loads in the framework of one system, and that is called HTAP, hybrid processing. And I should say that a very frequent use of this system is analytics in online time, when we have to provide the user with data immediately to provide dashboards, reports, and it should be done as quick as possible. As for Postgres, this is an OTP system, and at the same time, we can also run analytical system there. But what we will get there? We can take test ClickHouse, that is analytical system, that could work there really much faster, considerably faster. What are the main reasons for such speed? Well, the speed is first identified by the initial development of the system, where we have to store information a certain way, line by line. Data storage, we sometimes waste time where we have to unpack every single line, and yes, we have to spend time on that. Well, inevitably we have this isolation mechanism in a place that also requires some expenses on each line. We also have planning and plan execution, and this is not always done in the best optimum way. We don't always have to optimize as much as possible. I would say that the optimum plan or optimum plan execution, they require a lot of time, even if you have to retrieve just one single line. That is why one single a lot of things that they are meant to just for some other type of load. However, we have certain approaches to make Postgres SQL work faster with the analytical loads. We can analyze two types. The first one is computing and calculation. Here we have two major approaches here, that is query compilation and also vector-based vectorized engine with Spark uses compilation. ClickHouse uses vectorized engine. As for compilation, it's used for quite a limited number of cases. What about JIT? Why does it speed up analytics, and why does it speed up anything at all? In the Postgres, JIT, it does not compile the whole plan completely. We don't get just one program that is executed and provides us with certain results in form of lines at the outcome. It allows to transform certain things there or unpack lines, and as a result, quite abstract general code turns into the machine. We don't perform there any indirect transition, which is very often faster when we perform it with the processors. But unfortunately, sometimes we compile only separate lines. It means that the acceleration is not that high. It can be only twice as faster, or we can use just this kind of acceleration using analytical tools. It's worth mentioning that apart from plan compilation, we also need to think about plan execution model. Right now it goes from the top to the bottom, but usually when we talk about analytical system, they do it a little bit different. So they transfer recurse in a cycle, and we start from lower layers and to go upwards. And these cycles can be, unfolded by the processor. So actually we can read get something similar to vectorization or vectorizing in Postgres. Or we should say that this path or journey is quite long, but at the same time quite real one. Another option is to use this vectorized engines, and it's not so that easy either. We can have different approaches here. We worked with a number of some of them, but not all of them work with Postgres, and they do not give any momentum or do not accelerate progress speed for Postgres. So as for storage, like I said, it's very important for analytics when we have column-based column just to retrieve data as fast as possible. We have Z-store that allows to do that. And if we have queries, we can get quite a decent, good results. I haven't checked all those figures on my own, but that is quite logical. And if there is enough space for the data in memory, then we can also make columns in memory. And we can create a column-based index. It has not been done yet, but we have a startup called Swarm 64, which is optimized by Postgres. They have done that. Apart from optimization for such a universal system, we also need to make a difference between such queries. Like I said, so we have TP queries, which are critical for business, and they cannot be put aside somewhere. They should be accomplished, and so they should be prioritized. At the same time, analytics takes a lot of time, and we could cut down a little bit on this priority and spend a little bit more time on that. As for making such a difference between queries, we have a number of approaches. One of them is quite apparent, and those who have worked with Linux what you think is to use C groups. You can use resource groups in Greenplan. Of course, the major advantage is that's very much dependent on the type of system. Another option is to do it at the Postgres level. We could do this prioritizing at Postgres level. It means that we can insert certain sensors in a function. We can calculate the number of pages, the operating time of CPU, and yes, it is available already in Postgres Pro, even though that is closed, but at the session level you can set priorities. And so the last but not the least is to use asynchronic replics for analytics, also quite a popular solution. The only aspect that you need to think about relevancy of your data, because very complicated analytical tasks, they have a certain impact on log acceptance from the master, and there accordingly that data can be received with a certain delay. So you might use different approaches, but what about relevant data? How it can on also replication and how it is organized, and during the query, for example, you can wait a little bit for the logs to actually reach the desired point in time. That is something that I wanted to say about such an aspect as the type of load. The next aspect is scalability, and this is also an important thing. Internet companies have been scaling up for a very long time. We all know that. But as for corporations today, they also create their cloud services and web and mobile application. Well, actually, in corporations, we also have certain requests for scalability. We have a number of solutions. So how can it be done? How we can scale up the system? It depends on where we have all those bottlenecks. If we have, for example, reading loads, we can add more replics. If we have an increase in the volume of data, we have partitioning. It means that we can segregate a table in a number of physical sections, and so then we work with those sections. It's more convenient for the system to work with them, just to work with queries and do all the other things. And at the same time, you can run a lot of processes in parallel, but still we are limited by one node, and inevitably okay, let me put it this way. When it comes to replics, yes, we have two nodes, but I'm just going to show you what I mean on the next slide. So there are a lot of cases when we understand that those two solutions are not just sufficient, and they are listed here. The first one is analytics, something that I have previously mentioned. Apparently, if such queries are really heavy, then one node is not enough, and sooner or later we still have to run those processes in parallel for them to be performed at the same time. Then also we have full text search related problems, and also here is a number of cases when for transaction loads we can also resort to sharding. This is when we have write and read at the same time. Replics are of no help here. Then big data volume. That is why we can segregate all that in partitions, but still might lack certain resources. And also complicated logic, while I mean all those inserts. If we always worked with heavy parts every single time, that it's overlap with the second point, and we might have certain problems with the speed. Sharding in Postgres is already available, and it can be presented and be used with partitioning plus FDW. I'm gonna talk a bit more about that. Here I just shared a part of code that you can use in order to create a cluster from two machines. So the first one can be performed on the first machine and the second one, but like a mirrored on another machine. After that, we receive a shard system, and there the coordinating function will be performed by every single node, and you can go to any of them to see all the queries. So they will all be visible, and metadata will also be available. You will see what kind of metadata is located where exactly, on which shard, which is really great. Seems like everything works, but then we'll see that it's not as easy as you think. But anyway, well, this is already nice, so it means that we already have a certain mechanism. We can work different shard depots based on particular ranges. Let's look at partitioning, and also on particularities related to this process. Something that we should bear in mind if we talk about advantages of this approach and what is particularly good for sharding. So for partitioning, I have already mentioned what it means. It means when you want to perform a breakdown of the table into smaller parts, or segregated in smaller parts. We have a planner, and during this process, well, this kind of person can work with a query the more optimum way. We can resort to partition and pruning. We can work just with smaller amounts of data based on your needs. It works allows to save a lot of time, and we here you can understand that we can select on those partitions on those parts that we really need. So we retrieve it from the tables. Another mechanism is partition-wise aggregate and joins. We can also perform this function, and if during planning we understand so that joins and aggregates can be performed in the framework of one or a number of partitions, we do this, and all the data it's all within one partition, and of course we get done within the desired partitions, and then they can just be put together. We don't need anything on top of that. What is not the case for some other cases, for example, partial aggregates. This is the case where we have to perform pre-aggregation or partial aggregates. So that is also supported by partition, and we have parallel execution.
And in all those partitions, we can do the right calculation. And we can run the query the right way. And last part refers to optimization, part refers to sorting. Apart from all said, there is a good support. At the parent partition, we can create an index, and it'll create all the child partitions, and also we can create the unique index and a primary key by partitioning key, and external keys are fully supported, etc. My colleague was talking about all that in very detail yesterday. It's a really good system and fast developing system, and there is a lot of it in there, and there are only, well, how do I put it? Some lesser things are there. Well, we are looking forward to some updates and so on, but they're of less importance. So this is partitioning. The other part of sharding in Postgres is remote partitions through FDW mechanism when they are located in different servers. Basically, this FDW mechanism, it has initially been developed in order to be able to voluntarily randomly connect some third-party systems, not necessarily Postgres. It can be Oracle or something else. That's why it's quite, well, general, so to speak. There might not be some optimizations in place that would work only for Postgres. Well, there is an extension there that has different functionality to connect to different systems, and there is this FDW extension too, and there they have some optimizations too, but general FDW code, it's like an obstacle to creating a totally optimal solution. But you know, these are some general matters. So what's the difficulty with remote partitions? Why are they not running as well as the local ones? Well, the main reason there is that the planner has to think whether to execute the query remotely or upload the data and do it locally. It's called push down, a new dimension. And how it's working is very important for sharding. It's very important to understand how queries are executed. So if we didn't have push down, then we would have done well with queries with small amount of data. If we just filter the queries from the very beginning, and we have some tiny things left that we have to upload through the network. But if we need to run some calculation, and if the aggregator has to provide it with some small data, and on the input there is a lot of data, then it's complicated. So what kind of conditions do we have for push down to be working? Well, there is an overlap, a little bit of an overlap that it supports partitioning. Well, I must say that that works in a connection. So if in partitioning something is missing, then FDW won't help us. So there is partition-wise optimization, and in FDW they also got them, and it's cool because we can join and aggregate partitions and bring in the results together, like compiling them. And there is DML, then we can also introduce some changes in partitions remotely. But we need statistics too, so there's a planner. And we need to understand what's the best way to do it. We need to let push down understand, and for that we need statistics. And for such partitions, statistics is collected inefficiently, and it leads to the fact that we have to collect all the data for this partition to the node that sends the query, and there the statistics is calculated locally. So this is kind of costly. Apart from that, you need to specify parameters the right way. So it's like tuning the system and how expensive it is to receive the line, how it's expensive to launch a query. It may vary, and it doesn't make sense going deeper into it. And there is a sad part what's not supported yet. I took it from status classification. The type of queries which distributed planner can plan and send out. So that's what not supported. More complex partition-wise queries, partial aggregates, and if there is a combination of this function, then it won't work. Partial aggregates are not working. Insert select, they're not working. Well, basically it could have been done. For instance, we select data in one partition, and we paste into this data into some table that's there in the same partition. Wow. Then subqueries, parallel execution, and shuffle requiring queries, but it's similar to very complex analytics when we are calculating some data. Well, when we are having some non-partition-wise transaction and we need to send data between two different partitions. So join aggregation. DDL is not supported, and there is not such a notion as global tables. So it's clear that as of now, FDW requires some work. Here we have a bit of some information regarding implementation, why it's not everything's optimal. Well, it's determined by by the fact that it's a general solution for connecting external systems. That's why some things are not done in an optimum way. For instance, we are selecting something, selecting one line, and it turns into 5 lines, and this command turns into 5. Open transaction, creating point, do fetch, and so on. Of course, you can work around telling it. work around it. And FTW uses one connection between hosts, so there will be a lot of connections created. Well, wait. This is, yeah. This interferes with parallel planning because we can't. Double planning. When we send a query to a remote host, so it's not planning. We plan here, then we send, then we run e-parsing, then we receive the text of the query back, and then we are planning for remote execution, and that interferes with aggregates. Because in partitions, we were making plans for calculation. Here we cannot send, so yeah, the rest will open questions. Third thing about universality is the consistency model. Traditionally, databases were working on OneNote, and in terms of consistency, there was this requirement that transactions had to comply with ACID properties. In distributed systems, they had their own consistency. It was mainly about how the system sees several copies of data, for instance. So you can call it replica consistency. And when new scale systems appeared, when distributed systems started appearing compliant, ACID compliant systems, these two these two types of consistency started coming closer to each other, and now we have not only to check the isolation level of transactions, but we also need to make sure that distributed consistency between nodes also has to be in place. As for Postgres and consistency, so if we are creating such a distributed system, what do we need? We need transactions. And the standard that we are used, we don't need anything else, and we need to make sure atomicity, and you can do this with the help of classic 2PC mechanism, but it's locking, and high availability should be in place. And isolation in regular Postgres, it's implemented through MVCC. It's basically snapshots. So each transaction sees a data snapshot, its own data snapshot, and it does not interfere with things. So this mechanism can be done distributed in a distributed manner. There is a centralized, a decentralized approach. Decentralized is more interesting because there is a clock algorithm that we have implemented in our company, and well, it requires clock synchronization because physical time is what's used for snapshots. But nonetheless, it's implemented in such a way that if there is some discrepancy in terms of time, still you can ensure the isolation level to be good enough for repeatable read. But the second kind of type, or the second part of consistency, as for that one, there we have good consistency if within session customer is connected through one node, and if client goes through nodes within the session, it will be worse. And linearity is not supported. So if you take a look at Cockroach, their system is strictly consistent, and they spend a lot of time on that. And if you want to have a universal solution, a good approach is when you have a choice. Whether you create such strict consistency or not. And SerDB and ScyllaDB, they show big difference in terms of performance. And here we have a connection with analytics. In the universal system, everything depends on everything, and everything has to be regulated. So let's briefly finish with all those aspects. I want to tell you a bit about clouds. You can't live without them, and this is a very interesting sphere. And as for data, well, JSON is very popular, and I think it's been popular for a while, but I've been talking to Oleg, and they have really cool progress there, and you can check out Oleg's presentation. I was really surprised that there are such cool changes implemented. And of course, interface monitoring and failure resistance and so on, it's very important. So what kind of conclusions can we make? Universal system based on Postgres is a long way to go. You have to work on it, and there is business need in it, and if we ensure Postgres reliability of all of its functionality, and business has been asking for it already, and if everything's is there, it's great. And in vanilla, we already got a great foundation that has to be developed together with community, and you can get very good results. So these are the conclusions about the universal system. Now briefly about Shardman. We have created using vanilla tools. And what kind of opportunities do we have here? Here we have fail proofing. And there is a certain approach to locating replicas in master in such a way that, well, such a replication groups are being formed that utilize machines well, because on each node we have master and replicas, so it's failover safe. Cluster management tools, you need to rebalance things, delete and move things. There is partial support of distributed DDL, and if you can send query to different nodes without changing, now it's working. We'll create some minutes, play some trigger or something. And if you need some parsing, some need to introduce some alterations, changes, well, it's not yet there. Global tables appeared, distributed transactions based on clock-SI algorithm, and two-phase commitment backup, and optimizations that aim at mediating the drawbacks of FDW that I've mentioned, like asynchronous work in different FDW partitions, copy from for FDW partitions, and fast load utility. And we have optimized 5 commands. Well, we have optimized 3, and we need to work on. We started routing through FDW, then we started receiving fast statistics, short JSON, and everything comes fast. And we have optimized join push down. Briefly, how you deploy a cluster. It's very easy. Oh, there is a dependency on etcd. Then you place packages. Shardman utils is basically utility configuration daemons. This daemon, it manages stall clusters and learns, gets information from etcd, and the utility uploads information, which clusters and where they are, what to do with them. After that, we add necessary nodes. Everything is done through the same utility, and this is it. And you can connect and you can create table of simple syntaxes. So it's very easy to try it. Performance. As of now, it doesn't look as perfect as we want. It's like some single queries. They can be scaled linearly, and you can create aggregate of separate partitions if you need, and it'll be everything will become much faster. Distributed transactions, they work well. Well, of course, you lose some speed, but it's not something critical. We must note here that before that we had some specific queries, and here we have a different situation, and here we can scale better due to FDW features like having 5 commands instead of 1. So these are the results, and we have optimized it. And apart from optimization and copy, we have added shorter node, and it works with data even faster. So these are the results that we got.
I also wanted to say a few words about Preplan. Of course, there is a lot of work ahead in terms of optimization. Main concentration will be on OLTP, and there we will have to think about FDW. I have mentioned quite a number of aspects that will have to be considered, and then we will see what will come out for that. But globally, I think that we are still moving towards some universal approach. Second thing, we need to have a built-in failure-proof core. And this is a separate area. I think that we will manage to change these external utilities, and together with the community, we can think about how to do that, how to build it, and in integration with web interface and with clouds. Well, as for clouds, that's a separate story. There are a lot of also interesting aspects also related to computing, and I think that this domain can be considered as a separate approach to architecture that has to be chosen in order to understand where it should move and how we can work with shared system, distributed system. And of course we will be thinking about that. Thank you very much for your attention. We will be giving away this product for free in the first version, and of course we will be supporting it as much as possible. It of course needs to be verified. We will be waiting for any type of feedback. It will be nice to find out more about that. So I think that is basically it. Thank you very much, Dmitry. That was really interesting. And here we have questions in the chat, but I'm pretty much surprised that some people didn't have the courage to send it right in the chat, but they sent it directly to me. So, question from the chat. Speaking about FDW, there have a lot of constraints there, but what about the PL proxy? Well, I think that I cannot comment on that because we haven't worked with that, at least in the framework of Shardman. But as for pullers of a proxy, they will still appear in the system in a certain way because we have such an architecture in Postgres. We have a limited number of connections there. Only a limited number is allowed. And speaking about PL proxy, I just want to say that this is a functional cover that remotely can trigger functions, but the point is that it changes interface quite considerably, and I don't think about any applications that could switch to a PL proxy. Those who were initially based with regards to PL proxy with a functional interface, yes, that could be the case, but those already exist and it's done. Well, again, another question about FDW. About FDW, as for it, it also supports PTC. Yes, it has been the case for quite a long time, and so now their efforts are being made to adopt those changes. As for our patches, well, I think in version 13 we don't have that, because we have just stayed with our patches. But as for the new, now, yes. But apart from PTC, there also has another feature where deadlocks for not deadlocks, but those suspended distributed transactions. We had an issue with them. Right now, for example, we have a feature, external server that can work with them together with PPC. It would also add a core to that. Well, actually, speaking about this approach, that everything will be there in the core at the end of the day. I think that this is the correct approach. I'm thinking. Thank you very much. Actually, I guess that people were really listen to you very attentively, and here we have a big number of questions. Here are two interrelated questions. The first one, how we can understand master plus replica based on Stallone, and don't you think that it's a bit unsafe when the master and replica are on one node? I think that you should extrapolate a little bit more on that, then we will understand how it works. As for master replica, this is like a mechanism for providing high availability. And actually, if something goes wrong with the master, then we automatically forward all that to replics. And every shard here is included in cluster stones node. It's available as for master and replic on one node. Honestly, I don't know what problem could be there. I think that we need to think about how they are allocated on one node. So master of one shard and replics of other shards, they allocated on other nodes. For example, we have 3 replications, then we have all. Cluster is segregated into 3 and every nodes, and every 3 nodes includes master one of one of shards and 3 replics of the other 2 shards. So as a result, we can have efficient utilization of resources. Otherwise, this replica can attach logs in one processor, but this is a multi-core machine that is not efficient. Probably the idea was that on one node, so the replics of another master, not the same master. Yes, I should have precised that. No, and is it possible to shard an existing table? Not yet. We need to have a partitioned table. I think that if we learn to do it with partition, probably it will be possible. Everything that is done with the help of partitioning, with partition, probably it will be possible. Everything that is done with the help of partitioning, there is a big chance that there will also be done with partitions of FDW table. I just want to say that, just make reference to yesterday's presentation from Anastasia Gubelnikova, where she talked about tables, existing tables. It's not possible to partition it, not to mention to be sharded. And the next question, very often in the project you have more than one big table that requires optimization. Do you check out cases with this situation? Honestly speaking, I cannot answer this question. I think that yes, but it needs to be verified. Me personally, I haven't done that. And the next one. I mean, it's all about wrappers. Don't you think that FDW should be specialized with regard to shardings? Just exclude everything that is not needed and probably to get connected to the external system and to use API external API engines for that. I just didn't quite understand for connecting external system what is meant here. Okay, then I will try to interpret this question. Instead of connecting through FDW, we can do it through API table in table form. So table then will look like a real one, but it will just be stored remotely. No, it can be done through interface access method, but the problem is that planner needs to obtain this information. For example, one can push down BP forms, or for example, what tables or what partitions, what partitions should be processed within a sharding process, and planner might not have this information. I've read an article some time ago about the shardings where there were talks about shardings, and there was such an argument put forward, and was said that planner knows more if it's done through FDW, so optimization is more efficient and it's more considerable. But also, instead of Postgres FDW, you can also perform the shard FDW and optimize some things there. We think about that, and I guess that it could be just as a spare option for FDW, but some things can be done in a more optimal way. You can use its own module for that. That's what we think, but we still also need to think how it can be optimized in a better way. I cannot tell you just like that. Since we started to talk about table access method, what about column storage? Well, I actually mentioned that on one of the slides that we have column indexes and they're closed, but if needed, they can be used. But restored, this is available. But a shard, so far, it does not give any answer about that. No, but I think it can be connected and it will be working. So, and actually one of the most interesting questions for everyone, apart from Sharman star packages, do you have document stores anywhere else? Sarts. No, we don't have any. I would like to say that Sharm is made based on the SHEM that's available in public access. It has been accomplished, but I don't think it's worth looking for there. I would say that it is presented there in experimental way. As for docs, they will appear later on. Thank you. So I suppose that we are running out of time, and I would like to ask you two more questions. Could you please say how a situation when we have node two masters? What will we do with this situation? For example, if for example one of the nodes out of three goes down. Two masters. Well, actually, it is not restricted anyhow. There will be two masters. will there be notification for administrator, for the manager, that it needs to be restored as soon as possible? No, there will be just a bigger load for the other two nodes, and it needs to be recovered as soon as possible. And the last question, I think, because we're in out of time, is there a potential opportunity to the presentation, you mentioned a very interesting thing, that we have different types of consistency for different queries. And is it possible to actually use this handle, so to speak, prior to a query? Because, for example, I need consistency when I calculate salary. I need to have 100 consistency. And now, for example, I want just to sum up all the money obtained within a period of 1 year, and if there is a 10 kopecks or 10 cents deviation, there's no problem. Yes, so there is such a plan to do that, so that would be a good option to play with consistency, because right now Sharp, they just work the way they work, and so they're quite a strict consistency, but in the future we do plan to perform such a function, yeah, this feature. Thank you.